Hello and welcome. In this video, I'm going to cover the changes I've made to the MariaDB connector over the past few weeks. I have added prepared statements and a ping method. The functions for the prepared statements are to add a prepared statement. So you take your statement string and it returns a dictionary which has the statement ID in it. I then have a prepared statement exec select, and this is for select statements only, as they return an array of dictionaries, similar to how PHP's associative arrays is returned by their queries. Then I have a prepared statement exec command, and what this does is returns a dictionary which will have the rows affected, and or depending on the command, like an insert, will also have the last insertion ID. This can be very helpful for knowing what your ID is when you're inserting items, players, what have you. And then I also added the ability to close a statement, although this is not really that useful, as once a connection is closed, all those IDs are also closed. But it's there just for the use. And then the keep alive, the purpose of the keep alive is we need to ping the server at least every 20 minutes. I recommend at least 10 because the connector is a client and there's a 20-minute timeout when there is no activity. So what we do is we ping the server to keep it alive. Now let's check out the changes we made to the server. With the addition of the prepared statements, I've had to make quite a few changes since the last episode. We'll start with the DB tasks. There's no longer a type in the task because that is controlled by the statement ID itself, which I'll show you here in a minute. Other than that, the rest of the variables are pretty much the same. You have a success callable and a failed callable, and this is if the DB fails, and these are the functions that you will pass to run on these conditions. The DB connect is pretty much the same, except for we add a prepared statements dictionary, and this is a lookup table to reference a global ID of a statement ID to a connection statement ID. So when you run a statement, you pass the global ID, and it will use this table to look up the statement's ID on the connection. Everything else is pretty much the same. Do tasks, it's been changed, but the functionality is the same. Do callable, it's pretty much the same. I did add the set issued value, so when it is issued, it calls the DB signal dbcons change, so that way it tells the DB server, hey, our pooling has changed, can you go check the connection pooling to make sure we have enough, or we need to open up another one, etc. And then here it checks to see if we have a stale connection. So if you forget to change issued back to false, it eventually will time out and free the connection and notify the DB autoload. This section here checks your timer, your stale connection timer, which we set for 10 minutes, and then it will ping the server if nothing has been done in that time. Every due task that we run will also set the timer. This is where we added the 5-second signal to the time-lapse autoload. We now check every 5 seconds. It used to be we check every 10 minutes, but because we also want to check to make sure connections have not been forgotten. Here are the changes to the time lapse. I just added 2 signals for 5 seconds and 10 seconds. DB server. This one's got a lot of changes. We now add all the prepared statements that we are going to use here. We have an enum lookup that references the statement ID. Okay. Inside the statement ID, we also have what type it is. So here we have our types. So we moved the types from the task all the way over to the DB autoload. And here is a typical prepared statement. The question marks are for the past parameters. And what we do is this is loaded into the database, we get an ID, we reference that ID, and then all we need to do is pass the parameters. So in this case, we want to look up a player by their email address. And then we also have other to select to find their information by their ID. We can also check to see if their email or display name exists. And then we have insert statements. Again, we can insert a player using this by filling in the question marks with our parameters. And then a statement for updating their account. I also made some changes to the GetDB connection. We are using threads, and in threads are a little bit different. You can't use awaits in threads. It doesn't work because await only works on the main thread, which is where all your scenes are ran. So what we need to use is use an OS delay MSEC instead of an await. And if you notice here, I put a note. Don't call this on a main thread because it will pause the entire main thread, which is all of your scenes. This is only usable in threads, and that's why I changed the name of the function to thread only. You also have to call signals differently inside of threads. You can't just say db.signalName.emit. Again, these are called, all signals are called on the main thread, which is your main scene. So what you do is you emit a signal that tells the main scene to call this signal or emit this signal. So we do a call deferred. Call deferred is going to be our bridge between threading and non-threading. All call deferreds will call something on the main thread or run them on the main thread, and that's not all necessarily true. Sometimes the call deferred can call another thread as well, but that's something we won't get into. I don't see anywhere in the future. Change config is the same. Check connections. We're going to go through each of the buffers to see how many connections we have, to see if any's dropped. Remember that in the connection over here where we check to see if we had a stale connection or not, and was going to drop itself and delete itself here, queue-free. So there's no way for the DB server to actually know this has happened other than doing a call on the emit signal. dbconst changed. So what happens is this is called on the dbconst change. So then we go through, we say, oh, is this connection null? Yep. Remove it. Okay. And then we go through all the connection pools to see how many we have are available. And then we go through again to make sure that we have enough. Either we don't want either more than an excessive or less than what we need. Note the use of mutexes here. Create a mutex for each of the buffers. So that way we don't have a race condition when we're accessing it, especially with threads, because if we have one thread trying to access the buffer while another thread's trying to access the buffer, we could get undefined behavior. We could be writing over an index. So what this does is it locks this position right here. So when I say call mutex locks, all the other threads will wait for this to become unlocked. We do our process and then we unlock. So the other thread can then say, okay, I'm going to do this as well. This prevents race conditions. This is its main purpose. Onto the auth server script itself. Made quite a few changes here as well. We have different replies for the database. We have status bits for the account. This is for the status, so I just use a tiny int for their status, and we just do bit masking to figure out what their status is. And then we have functions. Now these functions, this enum functions, correlate to the dispatcher. So what we've done is we've created callables that we match to function codes. So when a function is called, we call it by an enum, a number that saves us on data. Okay, so when this is called, we call this function handle login, and I'll show you how this is done here below. Typical TCP connection stuff here. We got a TCP server. We're just going to listen under normal TCP. We're not going to do SSL because this is a gateway to authentication server connection. This should be private networked, either through VPN or through local network. So we really don't need SSL. All that does is slow things down. You notice here in the ready that I only have a connection to the change config. Reason why is when the config changes, it's going to emit the signal, which is going to call this config change function. The config change function goes through and makes sure that everything is set up correctly. It will stop the server if it's running. If it's not running yet, it's irrelevant. It'll make sure it'll set up the data correctly, and then it will run the server start. The server starts, pretty typical. We just create our connection. I use a helper tool called NetTool. Okay. And in NetTool, I've got SSL disconnects, getting data from a SSL connection. But right now we're only using TCP, so we have these functions right here that we're using. We no longer need the dictionary timed anymore because I've changed the way we're doing things. Previously in Orbital Wars, this is what I did, but with the addition of prepared statements, things are going to be a little different. So I'm kind of rewriting the entire network structure as we go here. This is our thread. All right, so let's go through the function. So on every process loop, we check for a incoming. First, we make sure that the server is running using a net tool. It says to check if the TCP server is running. Then we call incoming. We check to see if we have a connection. If we have a connection, we create a thread. We then pass the thread the parameters for the connection. So first we take it, and then we pass it to our thread. The thread, if you notice, we pass this thread, and the reason why we pass this thread is we'll need to close it later. Cover that in a second. But anyway, we have our TCP peer connection. This is where things change completely from the way I did it in Orbital Wars. Now what we're doing is we are getting the available bytes, and we're reading the function code. So instead of using a dictionary, transmedia dictionary, we're now just setting data streams. So in the beginning byte of 2 bytes of every stream of a TCP connection. This is another reason why we're using TCP, because this is easily controllable. In the TCP, we can control the flow back and forth very easily, and there really isn't much difference in this circumstance between TCP and using the multiplayer Ethernet. So we're getting the first 2 bytes. This gives us our function code. Then call the dispatch. See, here the dispatch call. So what it does, we get the dispatcher. So we use the code, we get the callable up here. Oops. We get the callable here. When we get the callable, it's to make sure that the callable is valid, which is down here somewhere. And then it will call the callable with the parameters. So in this case, let's say that we have a login. We're a function code of a login. Okay, so we're going to handle the login. We're going to go to the login. So the first 2 bytes have already been pulled off. So the next few bytes are going to be a T8F string. And basically these are encoded byte streams themselves. So there is a 4-byte header and then your string. The 4 bytes tells you how many bytes that string is going to contain. So and when we send those from the gateway, this is exactly how we build them. Okay, so we get the email, right? And since we're only checking login, we only care about the email for the first query. Okay, so this is how we build the parameters for the query. First, we need a type. Okay, this is the data type of the value inside of the database. So we'll go over here real quick. Sorry, I should have loaded this ahead of time. All right, so we got auth server, the player account, we have email. The email is a varchar 254. So that's the type that we have to set this as a varchar. These are types that are inside the connector. You can go look at them. There's a lookup table that tells you what they are. Okay, here we have a different field type. Okay, the field type, we have tinyints, unsigned, and these all match the names correlated to the values and the types in the table. We have to do it this way, unfortunately, because there's no way that when you send a parameter that to know what type it really is. We can imply a type, but it may not be accurate, especially in the cases of a decimal. A decimal is technically a string in the database, but it's a number. So you have to tell it that it's a decimal, because if you send a string and you say it's a string, it's going to be like, what? I'm expecting a decimal field type. So fortunately, that's the way we have to do it. It's the same way that PHP does it. I don't know of a single connector that doesn't have some kind of parameter setting to tell it what field type of each of the parameters are. I'm doing it this way. I think it's a little bit more clear and understandable. Back to this. All right. So we send the email. So we create the parameter, which is a dictionary of the field type and the value that we're going to send. Okay, this fills that question mark up here on a query. We have our question mark here. And this is what we're passing it from here. We also create a class, a helper class inside the script here. What this does is this allows us to return the query value. Inside of lambdas, all variables are local. So I can't just say, oh, pass an outside variable to an inside variable. It'll still think it's an inside variable. So what we have to do is we use something that has a global scope to it. And all classes have a global scope, even if they're made inside of a script. So this is global scope inside of the script. It's not globally everywhere, but it's inside the script. We technically could call it from externally. We could create it externally if we wanted to by calling the node name class name, but we don't need to do that. So we create a class instance here, and then we pass it in here. So that way our callables will set the variable to the global scoped class parameters. So then we push the task to our task, and then we get a threaded connection. And then we go ahead and call that task, and we set the issued to being false. Because once we do the task, we're done with it. We're going to nullify this instant or this reference to the connection. So that frees up that connection to be used elsewhere while we're busy doing other things. Namely, the reason why we're doing this is further down, we want to check the password. So if their status is checked, we get their status. We make sure that they're not locked or whatever. And then make sure our login attempts are good. We check the time diff since the last time they logged out. So we say we have a 15-minute timeout. So they can't, once they fail 3 times, they can't try their login again for 15 minutes. So it's the login temps here. So then this is where the big getcha is, and the reason why we want to hand that connection back. we're using Argon 2. Argon 2 is actually inside the module. I don't know if you noticed it or not. It's slow hash. It's purposely slow hashed. The fastest I can get this to run is 800 milliseconds, 0.8 seconds. That's a long time. That's a long time, but this thread is just sitting here processing the Argon 2 hash. So that's the reason why we hand the connection back. Okay, we can always grab another one. No big deal. So then we have the hasher. We have a function in the hasher that verifies the password by passing the password, the salt, and the password hash that we stored in the database, right? Which we have here. So we'll show you here. So we have the salt and the hash. Oops. We have the salt and the hash stored. When we create a password, we create a salt. We use the salt in the hasher to create the hash. It verifies. This is a function I have on the connector. It will verify the password based on the password to salt. If we're not verified, we add up 1 to our login attempts, and then we update the player login based on our login. And we have another helper function here, and we update the player login based on whether it passed or failed. This does is it goes through and it creates an update, uses it update, right? Update player login, which is here. Update player login. Right. It uses this statement ID because we're telling the statement ID in the task, in which the task knows what statement ID it belongs to, so that the dbcon knows what statement ID to reference to by its global lookup ID. And I don't think I covered this, but this is actually not only is this the statement, but this is also the global lookup ID. Is kind of why I did this, right? So each one of these has an ID. This is their global ID. And so when we pass that global ID into a connection, then it can look up inside of its internals going, oh, well, I have a global ID. What's its internal connection statement ID? We loop through trying to get a DB connection, giving a few milliseconds each pass, get the connection, run our task on the DB connection. Now, if you notice here, I don't have a return. And that's because this is passed by reference. And then this just returns on a failure because we're not verified. So basically what happens is we just update the account. If they're not verified, we call the put error to stream and quit. And what this does is it's down here. As all it does is that we have an error code that we pass it. So login failed. And what it does, it calls and says, puts into the stream. We have a 16-bit, 16-bit error code that we put into the stream. So all communications codes are going to be 16-bit, and they're going to be assigned. That way, I'm using negative values for errors, positive values for functions, DB functions. So we have a 0 is an OK. That kind of really doesn't do anything. Okay, and I'll explain that in the gateway. And then we have to pause. There's no, unfortunately, I tried doing poll, but there is a timeout delay. And I don't understand why you can't close a connection and it doesn't flush the buffer ahead of time. I'm assuming this is some kind of bug, or I don't know exactly without going into it to figure out why exactly, but for some reason, if you call a close on the connection, which that's all this TCP connection does, is just closes a connection. For some reason, if you call a disconnect, it doesn't push all the data through the buffer on the disconnect. And this isn't inherent to the stream pure TCP. There's nothing I can do about it. I don't know if it used to not do this, so I don't know what's going on with that. So what I do here is I just put in a delay for 100 milliseconds just to make sure that that data got pushed. Not ideal. Not really what I like, but it is what it is. And then here we also push the player ID, which is an unsigned int. You go here. Their player ID is an unsigned int. All right. Okay. So an unsigned int is 32 bits. So we just push their ID, and then we also push their player name. We push their display name. Wait 100 milliseconds for that to get pushed. We'll close the connection. Gone over time on this video, so I'm going to end it here. We'll continue on to the rest of the auth server and the gateway in the next video. Thanks for watching, and we'll see you in the next one.